SR is similar to what?
UVWT.
UVWT. Perfect, okay? So that's how we set it up. Now we're gonna pick any two sides that we already know that are corresponding and create our scale factor, okay? So what are two sides that we already know? Zoe? QR and UT. I love it, okay? Now, double check. So we're going to say, all right, we're going to put QR over UT, okay? Now watch. Which shape was my numerator? The first one. So put an N in there, and then was the larger one, which was UVWT, is my denominator, right? Put a D in there, okay? This is how important it is, because if you don't do that, I guarantee you're going to get it wrong, okay? So this has to stay my numerator the whole time. This has to stay my denominator the whole time. Got it? Okay, so let's highlight these sections that we're using. We're going to use QR, and it should be corresponding to UT. Savannah, what's up? Yes, I can move, okay? So, now, what are the two, or what is this side that I want to figure out? RS, right? So let's highlight that one in blue. What would be the corresponding side to RS? TW, okay? Now, double check that with your similarity statement, okay? First one we used QR, right? Q and R are the first and the last letters, right? And it matched up with UT. Are U and T the last two letters? So we're good there. RS is right at the end, right? The third letter and the fourth letter. And then TW is the third and the fourth letter. Okay, so we're good, right? We're good. So all we need to do is say, all right, this is going to be equal to, and then the second one, RS over TW. And then we just plug in what the values are. What was QR? So we have 5 over, what was UT? 10 equals, what's RS? X over 6.
Wait, why are you only picking those two sides? Like, can you pick any?
You could have picked any, yes. Okay? So if you picked 4 and 8, right? You would have gotten 4 over 8. That ratio is also going to be the same as 5 over 10. It's going to be 1/2, right? Because 5, we can factor out a 5. This would be 1 over 2, right? Same thing. 4 over 8 would be 1/2. Same thing with 4.5 over 9. It would be 1/2, right? So your scale factor, no matter which two sides you pick, is going to be 1/2, 5 over 10. You guys with me? Okay? So now the order matters, because if you wrote 6 over X, you're going to get a completely different answer. That's why you need to put an N and a D, so you ensure that you have your numerator and your denominator matched up appropriately. Yes, Mariana?
Does it always need to go from like left to right to make the numerator and denominator? Or
No.
is it just dependent on how you word it?
You can do however you want. If you made this one numerator and this one denominator, as long as you were consistent,
You get the same.
okay, you would get the same answer, okay? Now, if you made this numerator and this denominator, though, your scale factor is no longer going to be 1/2. It's going to be what? 2, okay? Because you're going to flip it, all right? But a scale factor of 1/2 and 2 essentially are the same depending on which way you word your ratio, okay? I accept, so like, if your scale factor, if I put it on the answer key as like 3, and you put on your quiz or test 1/3, those would be considered the same, okay? All right, so now how do we solve for X? Cross multiply. So this would be 6 times 5, which is 30, and then 10 times X, which is just 10X. What do I do? Divide by 10, so X equals? X equals 3. Go ahead and try 4. Is going to be 12 over 8, okay? That simplifies though, but in this case, we don't really need to simplify it, okay? We can just cross multiply and divide. It's going to simplify itself eventually, okay? So we cross multiply, we're going to get 15 times 12 which is 180. And we're going to get 8 times x. And those are going to be equal to each other. So we're going to have 180 equals 8x. You should have divided by 8, divided by 8. If you simplify this, you'll get 45 over 2 or 22.5. Remember, guys, I'm okay with either one of those. The 45 over 2 is simplified, and the 22.5 is a decimal. Yes?
Just an easier trick, you can break down the 12 and the 8 into a smaller number, 3 over 2.
Okay.
Just so that way you don't have to do such a big multiplication.
Oh, I like that. So the 12, Sophia's saying if you break down the 12 over 8, it becomes 3 over 2, which is correct. Yeah, I like that. And then when you cross multiply, you're going to get 45 over 2. Yeah. Now, if you were to write your scale factor, what is the scale factor of these two triangles? Now, 12 over 8 would be correct, but it's not simplified. What is the scale factor? It's 3 over 2, okay?
Would you take both or you would want this?
I would want it simplified. You're going to lose points if you just put 12 over 8. Now, this one didn't particularly ask for the scale factor, okay? It just wanted us to find the value of x. So if you don't simplify the 3 over 2, in this case, you're okay. Xavier, did you have a question? You're drawing lines over the lines of the little triangle to create a little figure for yourself, okay? Then you want to lasso it, and I want you guys to move it to each of the corners of the bigger triangle, okay? I want you to lasso it and move it into each of the corners of the bigger triangle. So lasso the little triangle, right? Draw a circle around it. I can't do it because I'm in explain everything. But lasso it, right? That means like crop it kind of, right?
Circle it with the little thing that you
And put it on top of the big triangle?
that thing.
Oh,
Brandon, what's up?
copy it.
Leave your what? Yes, it's right here. Okay? So you're going to copy it, and then I want you to paste it, and I want you to move it around, like line up the top part with this triangle, line up the right part with this triangle, and line up the left part. And what do you notice? Ah, what's all equal?
The triangles.
The angles, okay? So whenever you have a triangle that's similar, okay? This is the idea behind it. This angle is going to be the same as this angle. This angle is going to be the same as this angle. And this angle is going to be the same as this angle. So long as they're what kind of figures? Similar, okay? So I want you guys to visualize that, okay? That's why we're moving that triangle around. That triangle should fit perfectly in every single corner of the larger triangle, okay? That means that it is exactly a similar triangle, okay? So each of the angles are congruent. Make sense? Kind of? A little bit? All right. Now, the theorem that we're learning about in today's class is if only two angles of one triangle are congruent to two angles of a second triangle, then the two triangles are similar. So only two angles need to be congruent. Do you think that we only need two angles to prove that two triangles are similar? Christian?
Because since all the angles in a triangle equal 180 degrees, if you know two of them, then the third one has to be like the remaining value.
Very good. Okay. So if two angles in a triangle are the same, right? Let's say this is x and this is y, right? Then D would be what value? X. And E would be y, right? So the missing angle, which is F, can be represented by what? 180 minus what? Minus x minus y, right? How could we represent C?
The same way.
Yeah, 180 minus both the angles, which are x and y. So are these not the exact same values?
Yeah.
So then we just put a third congruence mark. So guys, as long as you have two angles inside your triangle, you know that the third angle must also be congruent. And if three angles inside a triangle are congruent, what do we know about those figures? They're similar, okay? They are not congruent though, okay? Because congruence means that all the sides are the same length. And that we don't know.
So all the angles can be congruent, but the actual triangles can't be.
The sides of them are not, correct. So all the angles are the same, but the sides are not. Now let's think about this. Do you remember when we had all those theorems for proving that two triangles are congruent?
Yeah.
Was angle a congruence theorem?
No.
No, right? We need at least three pieces of information, okay? Even angle was not a congruence theorem, okay? So remember that. This theorem is not a congruence theorem. It's a similarity theorem, okay? And there's only one similarity theorem for these triangles, okay? Now, would this apply to a quadrilateral? No, okay? Because if you only know two angles in a quadrilateral, are you for sure that the third and the fourth one have to be the same? No, okay? Now, what if you knew three angles in a quadrilateral?
Yeah.
Yes, okay? So as long as you know every single angle but one in your figure, then you know that the two shapes are similar, okay? Now, there's no theorem that you guys need to know for those other figures, okay? The only one that we're going to be dealing with for these are similarity theorem, okay? Do we all understand where this came from?
Yeah.
Any questions so far? Comments, concerns? All right, let's do an example, okay? Tell me whether the triangles are similar or not similar, okay? Take a look at the first one. We're not given any of the angles, okay? Now, if it's hard to see, go ahead and draw your two triangles with a highlighter. So let's highlight this little one in red. And then let's outline the bigger one in blue. All right, and we need to start piecing some information together. Are there any angles that are congruent based on this figure? Xavier?
The one at the top.
The one at the top, very good. Because it's a shared angle, right? So it has to be congruent to itself. So put a mark there. That's the first one. Anything else?
No.
What?
Oh wait. The two bottom ones are similar to the other two bottom ones because linear pairs.
Close. Let's use the fact that these two lines are parallel. Christian?
They're corresponding angles.
Very good, okay? So check out this angle, right? It should be the same as this angle because Christian said that they have a relationship of being corresponding. Because is this not two parallel lines cut by a transversal? They are. So those two angles become corresponding. Now, that's enough to say, okay, we can use the AA similarity theorem and say, what about these two triangles? They're similar. So they are check similar. School's out. Cool. All right. B. Oh.
At least two angles.
Yeah. Two angles are congruent. So what theorem can we apply? AA similarity. Which says that we have check similar. All right. C.
Oh.
Xavier, what do you think?
Similar.
Why?
Because the triangles are congruent.
There we go. Okay. The line in the middle is a shared side, so they're actually congruent. They're congruent by what theorem? Side angle side. And are congruent figures always similar? Yes. Are similar figures always congruent? No. Okay. So these two triangles by side angle side are congruent. Therefore, they are similar. Guys, are we allowed to say that these two angles, before saying side angle side, do we know that those two angles are congruent? No. Okay? They would have to drop a perp there, a perpendicular symbol, for us to know that those two are congruent. Okay? So we don't have enough information to just drop that in there. Mariana, what's your question?
The other angle, since it's on the straight line, like, isn't what we said before, isn't it a correspond or a consecutive angle?
Which one?
The one on that side. Like the
No,
two far-
because we don't have any parallel lines here.
No, not the two closest ones, the 2 points.
These two?
Yeah, because isn't it? Maybe I'm just dumb. Aren't they also? You could tell that
They will be by side angle side, but we don't know that off the bat, that those two are congruent. Okay? D. No. Guys, one of them is a quadrilateral. Okay, so these are not similar. Not similar. Okay? People, we can do it. Okay, find x. So, guys, we're going to see these types of examples a lot in here. Okay? Do we know that the small triangle on the top and the larger triangle are similar? Yes. Okay, we just showed that in the previous example. So let's go ahead and outline them. One in blue and one in red. Make one your numerator, make one your denominator. Okay? So the big one's going to be our denominator. The smaller one up in the top corner is going to be our numerator. Okay? What proportion can we set up? Sophia?
3 over 4 is equal to 5 over 5x.
Not 5x. Close. Super close. So how do we find the length of this whole thing? Hold on. I'll go back. Give me 2 seconds. So n over d, which is 3 over 4, and then 5 over, not 5x though. What do you guys think it is? It's not just x. X plus 5. Okay. Now, I know you guys got lost here, okay? But let's walk through it one step at a time, okay? So, do you agree that this side right here, right, is the smaller side of this triangle? Right? It's going to correspond to this big side, right? If this is 3 and this is 1, what's the length of the big side? 4, right? So that's how we got 3 over 4. You guys with me? I added them, right? So this side's 3 and this bigger side is 4, right? We're cool?
Yeah.
5 is the length of this side, right?
Yeah.
Its corresponding length is this whole thing. Do you guys agree? Which is x plus 5. So it needs to be 5 over x plus 5. Okay? Now, we would go from here and we would cross multiply and then solve. Okay? So let's cross multiply. We're going to get 3 times x plus 5 equals 20, right? Then what do I do? Distribute. So you're going to get 3x plus 15 equals 20. Subtract 15 from both sides. You'd get 3x equals 5. Divide by 3. X equals 5 over 3.
How does this apply in real life situations?
Actually, a lot. Okay? Next one. Example 3. Now, the first part of example 3, we just have to come up with the similarity statement. So ABC is similar to what 3 letters of the other triangle? Savannah, give it a shot. EBD. Okay. So angle A is going to be the same measure as angle E. B is the same as itself, and D is congruent to C. Cool beans?
Yeah.
All right. Now, y equals blank.
Y equals,
How could we figure out y? Sophia?
You would start with BD over BC is equal to is equal to ED over AC.
Excellent. Now let's see how Sophia got that. She made the smaller triangle her numerator and the bigger triangle her denominator, right?
yeah.
So what's the side BD in the numerator? What's it corresponding to? BC, right? So BD over BC, which is 4 over, what's the length of BC? 7 should be equal to, what's ED?
Y.
Y over
8.
8. So my scale factor is 4 over 7, and I'm setting that equal to the proportion of y over 8. So once I set this equal, I cross multiply. I'm going to get 4 times 8 equals 7y. 4 times 8, I think, is like 32, right?
Yeah.
Wow, that was... So this is going to be 32 equals 7y. Divide by 7, divide by 7. 32 over 7 equals y. Leave it like that, because it's not simplifiable. It's probably not a word, but I said it. Okay? It's not able to be simplified.
I like simplifiable.
Simplifiable.
I'm gonna use that now.
Please don't.
No.
I'll look so bad as a
When
teacher.
my mom, she's working in the
Sophia?
3 over X.
3 over, you're super close.
X plus 3.
Yes.
3 over x plus 3. Okay? Because BE is this, right? 3. And then BA is 3 plus x. You guys with me? Okay. It is very tempting to put the 3 over x. But make sure you're accounting for the denominator should be the entire triangle. Okay? So how do we solve for x? Well, we have to set this also equal to what? BD over BC, or our scale factor, which is 4 over 7, right? Once we set these equal to each other, we cross multiply. We're going to get 4x plus 12 equals 21. You subtract 12 from both sides. You get 4x equals 9. Divide by 4, divide by 4. X equals 9 over 4. And I forgot to put y up here. It was 32 over 7. Rough, okay? If we know that AC is parallel to BD, we need to prove that these two triangles are similar. What angles do we know are congruent? Ariana? Good. Label them for me. Very good. AOC as an angle is congruent to, you said DOB? DOB. Very good. And she said because they are vertical. Excellent. Anything else? Emma.
Angle CAO and DBO.
Very good. Why are those two congruent?
Alternate interior.
Love it. They're alternate interior. So angle OAC is congruent to angle OBD because they are alternate interior. Xavier, what's up?
Also, angle BDO and ACO are congruent.
By what?
The same alternate interior.
Very good. So you can say that the other two angles, which are BDO and ACO, are also congruent by alternate interior. But remember, to prove that these two are similar, how many angles do we need to know? Just dos. Then we can say AA similarity theorem. I know, guys. We're almost there. Example 5. In one of our triangles, one of the angles is 18, one of the angles is 96. In a second triangle, one of the angles is 56, one of the angles is 96. Are the triangles similar? Ah, someone said they're drawing a triangle. I love it. Draw a triangle. Make one of your, oops, that's a bad triangle.
That's really tiny.
I know. One of the angles is 96. One of the angles is 18. Draw another triangle. One of the angles is 96. The other one is 56. How do we figure out the third one?
Oh, add them together and then subtract from 180.
Good. So we're going to do 180 minus both of the other angles. So it would be 180 minus 18 minus 96.
Does it matter where you put the angles?
No. Okay. 180 minus 18 minus 96. Someone help me out with that. I think it's 66. No, you're not using calculator. 180 minus 96. Borrow. This becomes a 7. This becomes a 10. This is going to be 4. This is going to be 7. Oh, we can't do that. So borrow again. This is going to be 17. 17 minus 9 is 6. 64 degrees. No?
56. 18.
What is going on?
Wait. Did I not subtract 18?
The answer is 84.
84.
180 minus 96 is 84.
Minus 96 minus 18 is 60.
Okay, so that angle is 66 degrees once I subtracted correctly. Now the angle over here, okay, would be 180 minus 56 minus 96, okay? That's going to be 180 minus 56.
How much easier this would be if you could calculate. 28.
It is 28.
This is going to be 4. 7 minus 5 is 2. 4. Then we subtract 96. Borrow again. This is going to be 3. This is going to be 14. 14 minus 6 is 8. 13 minus 9 is going to give me 48. So 48 degrees.
28.
It's 28.
Yeah, they're not similar.
See, we would make the same
It's
mistake
zero,
on the test.
Oh, you're right. You're right.
I wonder if you can test us so we can have a quiz with calculator and see how much better we do.
So we've got 28 degrees, 56, 96. Are these similar?
No.
No, okay? Because they do not have two congruent angles. Not similar.